3 field stations on 3 separate mountain ranges, each monitor their own small population of the same undocumented amphibian, a pale, spring-dwelling salamander first logged in the early 1990s and never found anywhere between the 3 sites. Every year, on a single night, each population erupts from its burrows into the open all at once, in numbers seen on no other night of the year. Reviewed independently, the 3 eruptions, recorded on 3 different mountains, by 3 cameras nobody synchronized on purpose, begin within 90 seconds of each other. The 3 stations were never meant to be a network. Each was built decades apart by different institutions to monitor different things, a watershed survey here, a rare plant inventory there, and each happened to sit near a seep spring where this species turned up as an incidental catch. Only in the last decade did anyone realize the 3 logs described the same animal, and only more recently still did anyone think to compare the dates. It is a small animal, palm-length, pale gray-pink, with the soft, permeable skin typical of amphibians that never leave saturated ground. It lives entirely within cold mountain seeps, springs that surface, run a short distance, and vanish again underground, and it has never once been recorded away from one. For most of the year it stays hidden beneath stones and root mats, rarely seen even by researchers looking for it directly. Synchronized emergence is not, on its own, strange. Many amphibians move together, spadefoots erupt after the first hard rain, spring peepers call within the same warm week, wood frogs breed in a single explosive weekend, once ice out reaches a threshold temperature. In every documented case, the trigger is a shared environmental cue that arrives at each population separately, at whatever moment local conditions cross the same line. The difficulty here is the geography. The 3 seeps sit on 3 different mountain ranges, separated by lowland basins the species could not physically cross, at elevations and orientations that receive weather fronts hours apart, not minutes. A rainstorm moving through this region reaches the easternmost station, by the network's own weather records, roughly 4 hours before it reaches the western one. The salamanders do not wait for it. The comfortable answer is that the trigger is not the storm itself, but something larger and slower that arrives everywhere at once. A barometric pressure system, a moon phase, a shift in day length that all 3 populations respond to on the same calendar date regardless of local weather. Under this reading, the 90-second window is simply how tightly 3 populations can respond to one shared, region-wide signal. The trouble is precision. A regional pressure system or a lunar cue can explain why 3 populations move in the same week, even the same night. It cannot easily explain 90 seconds. 12 years of footage show the gap between the first and last eruption narrowing, if anything over time, never once widening past 2 minutes, on nights when the recorded weather at each station was measurably different. Whatever the cue is, it is not behaving like weather. The stranger alternative borrows from animals that solve exactly this problem elsewhere. Reef corals and some marine worms hold an internal clock precise enough to spawn on the same night across an entire coastline with no weather cue at all, timed instead to something coded far more finely, like moonlight intensity measured over weeks. If this species carries a comparably fine internal clock, the 3 populations would not need to communicate, or share weather, or share anything happening this year at all. They would only need to have inherited the same clock a very long time ago. An inherited clock shared that precisely implies something further. The 3 populations should be closely related, more recently connected than their present isolation suggests. The network sent tissue samples from all 3 sites to an independent genetics lab, expecting, at best, a distant relationship consistent with the species being simply widespread and rare. What came back instead reopened the case from a different angle entirely. The three populations are genetically closer to each other than any of them is to a fourth, previously uncatalogued population found later on a mountain that sits, geographically, almost exactly between two of the original three. By distance alone, that fourth population should be the closest relative of at least one of the others. It is not. The three synchronized populations are more alike to each other than to their nearest neighbor. One explanation for genetic closeness without geographic closeness is an old connection, a corridor of continuous seep habitat since erased, along which the species once moved freely before the ranges it now occupies were cut apart by drier ground. Surveys were run along every plausible former drainage between the three sites, on the chance that a relict corridor population still survived, unnoticed, in between. None was found. Only dry basin, and the fourth population, unrelated, sitting quietly in the gap. The network's researchers split along a familiar line. The first holds that the corridor is real, but simply better hidden than the survey could reach, underground seepage, not surface habitat, carrying gene flow through roots no camera or transect could sample. The second holds that no plausible hidden corridor explains both the genetics and the 90-second synchrony together, and that the honest description of the record is three isolated populations that converged, independently, on the same precise clock, for reasons the data cannot yet supply. Nobody in the network argues the animals themselves are unusual. Seen one at a time in daylight, they are unremarkable amphibians, easy to overlook, easier to forget. What resists a comfortable filing is the two facts held together, populations too distant to share weather, moving in the same 90 seconds, and populations too distant to share ancestry, more related to each other than to their own nearest neighbor. Either fact alone would be a footnote. Both in the same species are harder to set down. The network has installed a camera at the fourth population seep for the first time this season, timed to the same calendar window the other three sites have followed for 12 years, to see whether an unrelated population converges on the same night anyway, or holds to a rhythm entirely its own. Nobody on staff will guess out loud which result would be less comfortable. The forest keeps its own records. If this pulled you in, subscribe. New mysteries drop regularly across every series in the archive project. The next episode's waiting.